Hi and a very good evening. My name is SYAHMI and I'm going to present Control Volume Lab. So the experiment that we're going to refer today is called Impact of a Water Jet. As introduction, water turbines are widely used throughout the world to generate power. And a perfect example is pattern wheel. And it uses the impact of water on its bucket vanes, which is fastened to its wheel rims, to generate a torque, hence causing the wheel to rotate and it develop power. And even though the concept sounds like really simple, but these turbines have a really high energy output and a really high efficiency. Hence, we need to understand how deflection of water jet can generate a force on the buckets and how the force generated is related to the rate of momentum flow in the jet. And hereby in this experiment, we're going to measure the force generated by the water jet striking either a flat plate or either a hemispherical cup. And you're going to compare the results with the theoretical values. So the objectives of our experiment is first, we want to determine the force produced by a water jet when it strikes a flat plate and also a hemispherical cup. So we're going to have two different variables here. And also we're going to compare the results measured with theoretical values calculated from momentum flux in the jet. Alright, so this is the experimental setup. So here on the top we can see there's a weight pen, and this weight pen is used to measure the force exerted by the water jet coming out from the nozzle towards the target plate. And also as you can see here, we have the target plate. So the target plate is used and replaced either by the flat plate or also the hemispherical cup, and the nozzle is used to create a water jet from the water flow coming in through the inlet pipe. Alright, so the methodology. First, we're going to set the apparatus and level the gauge to a balanced position. Second, we're going to turn on the water flow through the inlet pipe, and flow is increased to the maximum. So as flow is increased to the maximum, we're going to try to balance the weight pen, and by balancing the weight pen, we can know how much force is exerted by the water jet towards the plate. And also we're going to take the reading of water volume and the time interval so that we can find the flow rate. As we know, flow rate is equals to volume over the time, and also we're going to take 8 more readings as the flow rates are reduced consecutively. And we're going to repeat the steps above for the flat plate and also the hemispherical cup. And the results here, we can see that generally the force exerted by the hemispherical cup is higher than the flat plate. And here is the graph, and you can see that basically the theoretical values are lower than the actual experimental values. Alright, so as a discussion, as flow rate increases, the resultant force on the flat plate and hemispherical cup also increases. And this is true according to the calculations and according to the actual values that we get. And both experimental forces of flat plate and hemispherical cup are proportional to the theoretical forces, which means that they follow each other and they are correct, but they are higher due to experimental errors and reading errors. And these errors are made because we are not in a perfect experimental setup, and but still the values that we get is according to the actual follows the actual values. And as conclusion, the impact of jet forces on the hemispherical cup is almost twice greater than flat plate according to the graph plot that we saw just now, and is much higher. Hence, hemispherical cup is found to be more efficient in converting kinetic energy of water in turbines. Why? Because even though they have the same flow rate, but the force exerted by the water towards the hemispherical cup is much higher than the flat plate. That's all. Thank you.